All right, hi year 11s, and this is Mr. Lim here again, and this is our last video on rates of reactions. Last video for the year. All right, this is what we're going to be learning about, just changes the rate of reaction over time. Make sure you write down some study notes. Okay, so explain how the rate of reaction changes, rate of a reaction changes over time. So it slows down. Okay, so let's have a look. It slows down. It reduces the rate of reaction. Why? Because the rate of reaction changes over time because as the reaction occurs, reactants turn into products. Okay? If reactants turn into products, there's less reactants present. If there's less reactants present, there's less frequent collisions. Okay, and if there are less frequent collisions, there are less frequent successful collisions, which then reduces the rate of reaction. Okay, so because the reactants are turning into products, there's less of them, there's less collisions, and therefore there's less frequent successful collisions. Now remember, need to make sure you're using all of the important words, otherwise you're not going to get the marks. Okay, let's move on. Describe how to determine if a rate of reaction has finished. When all the reactants have been consumed, the reaction will cease because there's no further successful collisions. Okay, that makes sense, okay, because all of them have been consumed. Right, the end of the reaction can be seen when the gradient becomes 0. Okay, so let's have a look at this diagram here. Where is the gradient 0? Is it here or here? The gradient is 0 there, and the gradient is 0 there at the end of the reaction. Okay, so remember, a flat line horizontal is a gradient of 0. Okay, having a look at these two diagrams, can you tell which one's showing the concentration of reactants and what's the concentration of products? These are your reactants because they're being consumed, and these are your products because they are being produced. That makes sense. All right. In year 12, we will learn more about other things about when you've got the reverse reaction going at the same time, but don't worry about that one for now. Just know that when the gradient becomes 0, effectively the reaction has finished, and so therefore that's the end of the reaction. And remember, that also tells you something about the moles of the reactants as well from the last video. All right, and that's it. Nice and short.